Hey guys, Travis Gillespie here. Today we're going to look at the most common exponents and fractions. And in my class, I suggest to my students that they learn at least the first 15 to 20 exponents. And I'm just going to divide up into a few more columns here. 1, 2, 3, and 4. And this is probably all that we'll need, but I'll leave this extra space just in case. So I'll set this first column up with the variable x, and let's just plug the numbers 1 through 20 in here. 1, 2, 3, 4, 5, and 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and I might need just a little bit more room. We'll just put a 20 down. Let's go ahead and just grab that purple again. I'll continue that column down. From here, let's go and focus in on our next column. We've got to change the color, and I'm going to plug my variable x in again. So I'm going to use all of these numbers for x, but this time I'm going to raise those values to an exponent or a power of 2. So I'm raising to a power. Well, 1 squared is the same thing as 1 times 1, so we'll put 1 here, and 2 squared would be 2 times 2, which is 4, and 3 squared would be 3 times 3, which is 9, and so on and so on. So I'm just going to keep continuing to fill this out. So we have 25 and 36, 7 squared is 49, and 64, and 81 would be 9 squared. 10 squared, well, we've got 100, and we're going to come back and focus on 10 a little bit later. 11 squared, we have 121. 12 squared, you have 144. 13 squared would be 169. And 14 squared is 196. 15 squared is 225. And 16 squared, you get 256. 17 squared, you get 289. Followed by 324. Let's go ahead and fix that 3. I'm going to backtrack there. So 324 would be 18 squared. 19 squared is 361. Followed by 20 squared, which is 400. And this is a powerful list. If you can memorize at least the first 15, I suggest going to 20 if you can, because it will save you a lot of time when you move forward to tougher tests. So now let's go ahead and change colors and move on to x to the 3rd power, or x cubed. Okay, so again, the variable is the value in the first list. So this time I have 1 times 1 times 1. Again, it's going to be 1. 2 times 2 times 2. Well, 2 times 2 is 4. Times 2 would be 8. Followed by 3 cubed would be 27. 4 cubed is 64. 5 cubed would be 125, and 6 cubed would be 216, and 7 cubed would be 343. And if you're going to move on to memorizing any numbers raised to the 3rd power, I would suggest at least the first 5, but 6th and 7, if you can learn the first 7, they're really not too tough to memorize. And then I'd suggest learning one more. It's powers of 10. So powers of 10, if you can do those quick in your head, then you'll be okay. And 10 to the 3rd power, well, that is the same as 10 times 10 times 10. Well, 10 times 10 is 100, times 10 would give you 1,000. Now we'll look at exponents raised to the 4th power. So x to the 4th power. So again, I think you're seeing the pattern here. 1 to the 4th power would be 1 times 1 times 1 times 1, which is 1 still. And then we have 2 to the 4th power is 16. 3 to the 4th power, well, that's 27 times 3, which would be 81. And 4 to the 4th power would be 256. And if you're going to learn any exponents raised to the 4th power, I'd suggest at least the first 4, but there are a few more that will come in handy as you get into high school and college. So I would say 625 would be 125 times 5 would be 625. 6 to the 4th power is 1296. And 7 to the 4th power, or just 343 times 7, will give you a value of 2,401. Okay, from here, let's go down to 10 to the fourth power. Well, 10 to the fourth power, or just 1,000 times 10, will give you a value of 10,000. And let's take a look now at a pattern that's occurring. Actually, I'm going to put one more down. Let's go ahead and look at x. That's probably not going to show up that well, so we'll use yellow again. X to the fifth power. And the only one I'm going to look at is 10. X to the fifth power, or 10,000 times 10, will give me a value of 100,000. All right, so here's the trick when dealing with exponents. I'm changing colors, and you have a base of 10. Let's go ahead and underline 10. That's our base. Let's see if we can find a pattern here when dealing with exponents and that base of 10. Well, when your exponent is 1, or base 10 is raised to a power of 1, you have 10, or look here, you see that there's 1 0 at the end of this number. When you're dealing with exponents raised to the power of 2, well, notice here, there are 2 zeros after the 1. Exponents raised to the power of 3, there are 3 zeros after the 1. Exponents raised to the power of 4, there are 4 zeros, and exponents raised to the power of 5, 5 zeros. Cool, so this is just one of those quick, simple tricks when you're multiplying with powers or exponents.